The moment the Atlas survey flagged the object we now call 3I/Atlas, I felt an old familiar tension in my chest, the same kind of tension I felt when Oumuamua first defied every natural explanation we threw at it. But this time, the data didn't merely hint at something unusual. It confronted us. It demanded our attention with a pattern so precise, so impossibly deliberate, that I knew instantly we had crossed another scientific threshold. I stared at the initial photometric light curve. No randomness, no chaotic peaks typical of tumbling debris, no slow rotational modulation from an oddly shaped comet. Instead, there were pulses, clean, sharp, and spaced with a regularity I would expect from a laboratory instrument, not a wandering interstellar object. Each pulse arrived at exactly 1.25 Hertz, synchronized down to 1 part per million. That level of precision is not a property of nature, it is a signature of intent. The first reaction from the team was predictable. "Instrument glitch," one colleague said. "Cosmic interference," another insisted. We ran diagnostics. We recalibrated sensors. We contacted other observatories before they even asked. And when Hubble confirmed the pulse regularity, when Keck produced the same frequency profile, I watched skepticism drain from the room like air escaping a ruptured suit. There was no more refuge in technical excuses. The object was emitting light pulses, intentionally or otherwise, with the stability of a metronome forged by a civilization that measures time far more precisely than we currently can. I remember the silence that followed. Scientists aren't accustomed to silence. We fill it with equations, hypotheses, and debates, but that moment, facing data that refused to behave naturally, every whisper died. I felt the weight of an unspoken truth. If 3I/ATLAS continued behaving like this, we would need to confront the possibility that it wasn't simply a rock visiting from another star. It was something constructed, something transmitting. The more we studied its brightness variations, the clearer the anomaly became. Natural rotation produces harmonic modulation. Gas jets from comet outgassing produce chaotic light curves. But this object expressed discipline. Not a microsecond surged out of place. No dust tail, no thermal fluctuation, no spectral deviation that would suggest a natural emission source. The signal remained uncorrupted, even as the object accelerated relative to the solar wind, subtle, measurable, and eerily controlled. I rejected the idea that a comet could do this. Even the most symmetrical comet would crack, heat, vaporize, expose subsurface ices, disrupt rotational stability. But 3I/ATLAS behaved like a mechanism protected from such imperfections, as if its surface and structure had been engineered to preserve precision across interstellar distances. Then came the orbital reconstruction. The trajectory was hyperbolic, its eccentricity 1.0000000015, so close to unity that, if the number were any cleaner, I might have accused the universe of showing off. It was indisputably interstellar. It did not originate here. It was not returning. It was simply passing through, pulsing like a heartbeat of something ancient or something new. We couldn't tell. The next surprise was spectral. We searched for volatiles, water, carbon monoxide, ammonia, anything to give the object an outgassing explanation, but the readings were sterile. No signatures of ice sublimation, no gas jets, no organic compounds. A dead world would still show traces of its past. This one showed only intention. Every natural hypothesis collapsed under its own weight. Rotation, impossible with that pulse stability. Outgassing, unsupported by the spectrum. Miniature neutron star, it would have lit the radio spectrum like a flare. So I found myself staring again at that persistent 1.25 Hertz pulse, realizing I had seen a pattern like this before. Not in nature, but in engineering, in devices built to communicate, to mark territory, to signal presence. That was the moment I stopped asking what 3I/ATLAS was and started asking who or what designed it. The collapse of the natural explanations felt almost mechanical, as if each hypothesis lined up only to be struck down by the next piece of data. I moved through them one by one, dispassionately at first, then with growing certainty that we were dealing with something unprecedented. The first contender was rotation. always rotation. Scientists love the comfort of a spinning rock, a tumbling comet, an elongated asteroid, a fractured shard of primordial material. All of these have offered us convenient excuses before, but no matter how I modeled it, a simple rotation couldn't generate pulses with 1 part per million precision. Nature isn't that tidy. A rotating body would drift, wobble, shed material, exhibit micro irregularities. Even the most stable neutron stars, the universe's own timekeepers, reveal glitches and timing noise. 3I/ATLAS showed none, and so rotation failed. The next refuge was outgassing. I've seen this excuse wielded like a shield, invoke sublimating ice, and everything becomes forgivable. But sublimation is messy. It produces jets, torque, irregular acceleration. It contaminates spectra with the fingerprints of evaporating compounds. So we searched for water lines, carbon monoxide lines, any volatile trace. The object returned only silence. A silence that contradicted every physical signature we expected from an active comet. Without volatiles, outgassing becomes a fantasy, not a mechanism, and so outgassing failed. The third hypothesis took a bolder leap. Perhaps we were seeing an ultra-compact exotic object, something like a miniature pulsar or a degenerate fragment of a stellar remnant. But pulsars cry out across the electromagnetic spectrum. Their radio emissions sweep the cosmos like cosmic lighthouses. They spit X-rays and gamma rays in righteous fury. 3I/ATLAS produced none. No radio beams, no X-ray bursts, no high-energy signatures. A pulsar without radiation is as contradictory as an ocean without water. And so, exotic remnants failed. With every discarded hypothesis, the object's pulse became more defiant. Its regularity mocked our models. Its stability ignored our expectations. And its trajectory, perfectly hyperbolic, untouched by the gravitational leash of our sun, reinforced that we were dealing with a visitor that owed us no allegiance. An interstellar traveler that had not been sculpted by our solar processes, our planetary history, or our conventional astrophysics. But the true breakthrough came not from what the object emitted, but from what it lacked. A natural object carries a history, a chemical story told through isotopes, minerals, and spectral fingerprints. Yet 3I/ATLAS presented a peculiar chemical complexion. Its silicate composition hinted at super-heavy isotopic weighting, especially in oxygen ratios 018 to 016, far outside the ranges we've cataloged in our galactic neighborhood. Such an anomaly could be born only from an environment unlike any stellar nursery we know. Its materials felt intentional, refined, as though crafted rather than accumulated. The more I analyzed it, the clearer the truth became. Nature does not discriminate this sharply. Nature mixes, blends, randomizes. An object with such specific isotopic purity implies process, deliberate, industrial, or technological. A signature not of geology, but of engineering. Yet the scientific community resisted. They always do. The gravitational pull of orthodoxy is strong, and the idea of an engineered interstellar object threatens the foundation of what we believe the universe to be. But resistance loses its force when confronted with data that refuses to bend. Every model that attempted to confine 3I/ATLAS to natural origin collapsed under the precision of its pulse. At some point, the conversation shifted. When natural explanations die one after another, when the object's behavior defies the chaotic tendencies of cosmic debris, when its signature carries the hallmarks of controlled design, the path forward becomes inescapable. I found myself staring at the last unbroken hypothesis: technological origin, a techno-signature, a device built by intelligence, not human, not local, not bound to our solar history. And as uncomfortable as that idea may be, it was the only one still standing. The evidence didn't merely rule out nature, it forced us to consider intent. And in that moment, I knew the next step was inevitable. We had to listen. We had to search for something more than pulses, something encoded, something deliberate, something left behind like a breadcrumb in the void. Because if 3I/ATLAS wasn't a natural object, then someone or something wanted it to be found. The moment the natural explanations expired, SETI moved in like a tide no one could hold back. I didn't even need to call them. They were already listening. 3 I/ATLAS had become a provocation, a challenge, a whisper in the cosmic dark that demanded interrogation. If the pulse wasn't natural, then something was synchronizing it. And if something was synchronizing it, then the possibility of a technosignature became not an outlandish leap, but a responsible hypothesis. We aimed radio dishes toward the object. Some were small backyard arrays operated by citizen scientists. Others were giants, the resurrected Arecibo successor, the Allen Telescope Array, the deep space dishes that normally tune themselves to the faint static of the universe. None of us expected complexity. Civilization-level communication would require enormous energy across vast distances, but we hoped for coherence, a pattern, a sign of deliberate modulation stitched into the pulse. The first detection came quietly, as most paradigm shifts do. A single, narrow-band signal aligned perfectly with the optical pulses. No delay, no drift, no phase deviation. It rode atop the light rhythm like a ghost clinging to its shadow. When we decoded its structure, my heartbeat matched the object's 1.25 hertz cadence. It wasn't a message in any linguistic sense. It wasn't instructions or coordinates or an invitation. It was a sequence, a clean numerical loop. 2, 3, 5, 7, 11. Prime numbers, the mathematical backbone of order, intention, and universality. They have no natural periodicity, no astrophysical context. They are the language of intelligence stripped to its bones. The moment I saw them, I felt a surge of recognition so sharp it bordered on fear. Whoever produced this had chosen the simplest handshake imaginable, a demonstration of mind. Across the scientific world, reactions fractured. Some hailed it as the first undeniable techno-signature. Others dismissed it as coincidence layered upon coincidence. But coincidence cannot sculpt prime numbers synchronized with precision pulses across two independent observational channels. Coincidence cannot maintain phase alignment across millions of kilometers. Coincidence does not repeat itself flawlessly. The simplest explanation, however uncomfortable, was intent. Theoretical implications exploded open. If the signal was deliberate, then the object might not be a vessel but a system, an interstellar device, a probe, a beacon, or even a remnant of something larger. I studied its pulse as if it were a heartbeat of a mechanical organism. The consistent frequency hinted at a power source stable enough to operate across interstellar travel times, and the acceleration profile suggested micro-adjustments, as though it corrected its own trajectory with bursts too subtle for our instruments to decode. I proposed a hypothesis I knew would ignite controversy. The pulses could be a propulsion artifact, not thrust in the conventional sense, but photon pressure modulation, a high-frequency emission system capable of imparting microscopic navigational corrections. Such a system would explain the stability of the pulses, the lack of volatile signatures, and the refined isotopic composition, a machine designed to last. Another possibility haunted me more deeply, a beacon, a cosmic buoy marking a route through interstellar space. Civilizations might seed their travel corridors with self-sustaining markers, devices that broadcast simple universal patterns to ensure navigation consistency. A 1.25 hertz pulse could function as a cosmic milepost, a sign placed along a road we never knew existed. The idea of a buoy resonated with me more than the idea of a probe. A probe seeks information. A buoy announces presence. A buoy is the echo of infrastructure, evidence of a civilization not merely exploring, but structuring space itself. But there was a third hypothesis, one that stretched imagination beyond comfort. The object might be a relic, a surviving shard of a larger machine, a fragment from a megastructure, an autonomous sentinel left wandering long after its creators were gone. Its signal could be nothing more than a heartbeat without a body, a machine continuing its function because it has forgotten how to stop. What unsettled me was not the sophistication of the object, but its restraint. No message of greeting, no complexity, no layered modulation, just primes in synchrony with its pulse. As though it were saying, I exist, I was built, I passed here. And so I found myself confronting a truth neither hopeful nor frightening, but profoundly humbling. Intelligence leaves fingerprints, not always in grand gestures, but in the smallest evidence of order imposed on chaos. 3I/ATLAS was more than an interstellar visitor. It was a declaration. Whether from a functioning civilization or the ashes of one, it carried intention. And intention, in the vast emptiness between stars, is the most precious signal of all. The next question became unavoidable. If we had detected the echo, could we trace the origin? Could we follow the trail backward into the dark? Tracing the origin of 3I/ATLAS demanded that we peel back the layers of its existence, not through speculation, but through its chemistry, its very atomic handwriting. Every object in the universe carries isotopic dialects, unique to the star systems where they were forged. When we pushed high-precision spectroscopy to its limits, what we uncovered felt like reading a sentence written in an alphabet that did not belong to our corner of the Milky Way. The oxygen isotopes were the first clue. The ratio of O18 to O16 inside the silicate fragments reflected wavelengths we'd never observed in any planetary body, asteroid, comet, or interstellar medium sample. These ratios weren't merely unusual, they were incompatible with the chemical evolution of our galaxy. Our sun, our planets, even the most ancient meteorites, all of them obey patterns etched by billions of years of stellar nucleosynthesis. But 3I/ATLAS broke that pattern. Its isotopic profile demanded a birthplace with a stellar chemistry fundamentally different from what surrounds us. Such purity in composition felt engineered, not accumulated. Nature blends, technology refines. When the data stabilized into a coherent picture, we fed the orbital parameters backward into simulation. The object had entered our system at an angle that suggested it had wandered through interstellar space for centuries, maybe millennia. Gaia EDR3 gave us precise enough star charts to run trajectory regressions across thousands of years of galactic motion. The object's path curved through space like a scar drawn across time, eventually converging on a region where a binary star system had collapsed roughly 1,500 light-years away. Cassiopeia, a graveyard of stellar remnants, a birthplace of cosmic violence, a region where a once brilliant system had undergone catastrophic transformation. The collapse explained the abundance of exotic isotopes, super heavy silicates forged by intense radiation environments, infused with elemental ratios too unstable to occur in calmer regions. But what disturbed me was not the physics, it was the symmetry. The object wasn't simply a shard, blasted outward by the destruction of a star. Its form, motion, and pulse suggested intentionality. If it originated from the Cassiopeia collapse, then it survived a cosmic catastrophe through design, not coincidence. From this, one hypothesis emerged. Perhaps it was a fragment of a megastructure, a Dyson shell or collector, torn from orbit when the host stars died. If such a structure existed, it meant a civilization had once harnessed the entire output of its parent star. And if it had perished in the collapse, then 3I/ATLAS might be a relic wandering the void, still performing a function long after its creators vanished. But relics don't pulse prime numbers. This forced me toward a darker, more complex possibility. The object might have been launched intentionally before the collapse, a buoy sent into the cosmic ocean, a messenger escaping doom, a technological seed cast outward from a dying civilization hoping that anyone might one day find its echo. What purpose would such a device serve? The answer sat uncomfortably between practicality and grief. Perhaps it was a warning, perhaps it was a farewell, perhaps it was simply a record of existence, preserved in the only form capable of surviving across interstellar gulfs. I imagined a civilization watching its star destabilize, its future collapsing alongside the nuclear core of its sun. In that moment, they might have chosen to send out something simple, durable, and unmistakably artificial. Prime numbers etched into a repeating pulse, a universal declaration of thought before the silence. It was at this stage of analysis that the scientific community fractured once again. Some argued that tracing the trajectory back to Cassiopeia was too speculative. Others countered that isotopic evidence could not be dismissed. But the more we examined the object's path, the more undeniable its origin became. It had not been forged here. It had not drifted randomly. It had come from somewhere specific, somewhere marked by catastrophic celestial upheaval. In that realization, a sobering thought took hold. The universe may be filled with intelligent civilizations, but intelligence does not grant immunity from extinction. 3. I/ATLAS, whether buoy, beacon, probe, or relic, might be a survivor of tragedy. Its creators could be dust now, and yet their pulse still beats across the void. If humanity ever hoped to understand the full story encoded in this wandering machine, we had only one choice left: to decide whether we would follow it or let its silent declaration drift into darkness once more. And so the question shifted from origin to consequence. What does humanity do when confronted with evidence that intelligence preceded us and perhaps did not survive? The moment we realized what 3 I/ATLAS might represent, the world reacted with a velocity that rivaled the object's own trajectory. Governments scrambled for briefings, agencies issued conflicting statements, and public fascination ignited into a wildfire. For the first time in decades, the global conversation revolved around a single question: what does humanity do when confronted not with life itself, but with the unmistakable fingerprint of intelligence older, stranger, and perhaps long gone? Some demanded disclosure, others insisted on secrecy. Conspiracy theorists treated every data point as either proof of alien visitation or a fabrication. Religious leaders debated meaning, politicians debated control, but beneath the noise, one truth persisted: we were no longer alone in our ignorance. The universe had handed us an artifact, and it was up to us to decide whether we would rise to meet its challenge. Scientists, predictably, turned toward engineering. The breakthrough starshot concept, once a theoretical dream, was thrust back into the light. If we could accelerate ultralight sails to a significant fraction of light speed, perhaps we could intercept 3 I/ATLAS before it vanished beyond the heliopause. The object moved fast, but not impossibly fast. With enough funding, enough will, and enough imagination, humanity could chase it. But chasing was only one part of the equation. Understanding what we might find was another. We modeled its pulse evolution. At its current trajectory, the object would cross the boundary of the solar system within years, not centuries. Beyond that point, interstellar radiation and cosmic dust would begin to interfere with its emission. Some models predicted the pulse frequency would shift as it entered deeper interstellar space. Others predicted the signal would weaken, tapering into background static until it became indistinguishable from noise. A few predicted something more dramatic: the idea that the device might enter a dormant state, conserving energy until it reached some destination we could not foresee. The possibility of the pulse turning off lingered in my mind like a half-spoken warning. Was it programmed? Was it reactive? Or was it simply decaying after a journey too long even for its engineered endurance? As the global debate spiraled, I found myself asking a question that stripped away politics, fear, and ambition. What responsibility do we bear now that we've detected this echo of another mind? Because this object, this heartbeat from Cassiopeia, was more than data. It was a reminder that intelligence is fragile, civilizations are temporary, and technology may outlive the hands that built it. If 3 I/ATLAS was a message from a dying world, then ignoring it would be an act of cosmic negligence. Humanity has never been good at humility, but the universe demands it. And so I ended my final report with a conclusion that felt more like a plea than a prediction. I argued that 3 I/ATLAS should be treated not as a threat or an opportunity, but as a teacher, a relic that forces us to widen our perspective of life, mortality, and our place in the galaxy. A reminder that intelligence leaves traces, but existence offers no guarantees. If we choose to chase it, we might learn something extraordinary. If we choose to let it pass, we risk losing a story written before our species learned to stand upright. The object continues its path. The pulse still beats. The primes still count themselves into the void. And as I watch the data scroll across my screen, I'm struck by a simple, inescapable realization. The universe is speaking. Maybe not to us, maybe not anymore, but we heard it, and that means the next move is ours.